All right, geometry students, let's do some problems. Square, circle inside there's 8, so each side length has to be 2. Now, to figure out the radius, we understand that the top side length refers to the middle side length, so the radius has to be 1. Cool. So the area of the square is 4 side length squared. Area of the circle is pi times r squared. In this situation, it's pi times 1 squared, which is just pi. It's the area between. Well, area of the square minus the area of the circle would be the area of the space between. I'm going to find this length here. Once I find this length here, I'll find that length there. I'm going to use the Pythagorean theorem to figure that out. Look at that. So this is 24. Then I'll have 30 squared minus 24 squared. So I have 1/2 of my base, which is 25 times my height, 24. I'm gonna leave it like that. But you guys usually don't like that. So 1/2 base height, or other way around. Okay, cool. This is a soft question. I literally just give you a circle. Circumference is 2 pi r. So, or diameter times pi. I don't know why we don't call it 2r pi or d pi. Why do we do 2 pi r instead of 2r pi? Because it makes sense, 2r is d, and then you'd be like, okay, it's just diameter times pi, or double my radius times pi. We always have pi at the end of our answer. I don't know, some things in math, I question. Why do we teach it this way? Area is pi r squared. Why isn't it r squared pi? Right? Because it's like 16 pi is the answer that we like to write. We like to put the number, the amount of pi's. So, I don't know. Okay. Cool. Hexagon. What's the reason behind the hexagon being the bestagon is that if you take the interior angles, you find that this is 60. Since this is a isosceles triangle, you realize this is 60. This is 60. You realize you have an equilateral triangle, which split in half creates a 30, 60, 90 triangle. And we know the side lengths of a 30, 60, 90 triangle are 1, √3, and 2. So we could scale this. If this is 4, this is 2. So I'm going to double everything. This would be 2 root 3. This would be 4. So what's great about the hexagon is the side length actually equals the radius length. It's not something you memorize, it's something you figure out. Cool. Perimeter is easy. I just have 6 of these 4s, so 24. Area, different. I have a half of my base times my height. 6 of those. So I have 24 root 3. Area is pi r squared. Many of you can just figure out that r must be 6. You want to solve an equation, divide by pi square root. You should be considering plus or minus. We're talking about objects, which is why we only want positive answers. And then circumference would be 2r pi, 12 pi. So 2 to 3, 2x, 3x. He divided these two. This is 3 to 2. 2x times 3x equals 384. 6x squared equals 384. Divide by 6. Square root, only consider the positive solution. Cool. Trapezoids, well, split it into a rectangle and a triangle. That's what my calculus students do. They split things into triangles and rectangles because trapezoids we don't work with enough, so tricky. So I have this length here, we'll call x. Now here's a good question. 8x plus 1/2 base height has to equal 280. We're trying to find x, we can find it. Now we talk about question kind we got into towards the end of class, which would be like the area of a sector. We know the angle. Well, get kind of like the percent of the circle. Well, like pi r squared would be the area of the entire circle, but I only want this part out of my whole circle. So we like multiply by the part over the whole, the degrees of our 360. So here we see this 90 degrees. So if I want, let's say I wanted this entire shaded area, I'd say it's pi times r squared times my part over my whole, which ends up being a fourth. It's like a fourth of the thing. We don't want that because it looks like we want the entire circle minus this little part there. Well, there's two ways to do this. You can do the entire circle minus the little part there, or you can do 3/4 of the circle plus the triangle. So let's do both ways. Let's do probably the easiest way, which is 3/4 of the circle. This is way number one. It's 3/4 of the circle. Again, it would be like 270 out of 360, which is 3/4, plus the triangle. That'd be 1/2 base times height. So 25 divided by 2. That'd be one way. Second way would be the full circle. Now, minus that part. Well, we can get the quarter of the circle. So that would be 25 pi times 90 over 360, which is a quarter. That'd be the entire, and then I would subtract the triangle to get that taken out. So we end up with what looks different, but it's the same answer. If you take 25 pi and subtract 25/4 pi, you get 25 3/4 pi. And then subtracting a negative 25 halves will be like adding a positive 25 halves, so it works out. Cool, we have the area of the square minus the area of the circle. If the square's area is 25, each length is 5. This is 90, and that this is this, and this is this. This must be 45 degrees. There, you know the side lengths of a 45, 45, 90 triangle. Or you know to divide by √2 if you have the hypotenuse. So pi r squared. That's 5 over √2 times 5 over √2, which would be 25 over √4, which will be 25/4, or 25 halves. All right, pretty simple. We'll do more practice, make them harder during class before our next entrance ticket. Peace.